All right, so next up is 2.3, the idea of polynomial and synthetic division. So both these methods are used to divide polynomial expressions by another polynomial expression. So for polynomial long division, similar to how you did it back in grade school, we're going to set up a long division problem. We're dividing one expression into another, typically quadratics into cubics or quadratics into x to the fourth expressions. So we have this set up here. So we have 10x cubed plus 9x squared minus 6x plus 2. We're dividing this by 5x squared minus 3x plus 1. So we're going to set up the 5x squared. Let's use a different color there. So we're going to set up our 5x squared minus 3x plus 1 on the outside. On the inside, it's going to be 10x cubed plus 9x squared minus 6x plus 2. And what we're going to do is very simple. We are going to take the first term inside, and we're going to divide by the first term on the outside. So 10x cubed divided by 5x squared is going to be simply 2x. And that's what's going to go up top. 2x will then go up top. That 2x will then multiply with the outside expression, the 5x squared minus 3x plus 1, giving us 10x cubed minus 6x squared plus 2x. And then we're going to subtract that expression. Now, if you're careful with your subtraction, 10 minus 10 is 0. 9 minus negative 6 is a positive 15 because minus the negative. Negative 6 minus 2 is negative 8x, and then we carry down the 2. Be careful with your subtraction. You'll be perfectly fine right there. If you think you might mess up the negatives, you're going to want to do what I'm going to suggest in the next problem, and I'll be doing the next part I'll be doing going forward. So now we're going to do 15x squared divided by 5x squared. And we get just simply 3. So we put a plus 3 up top. And again, that 3 multiplies the outside expression, the 5x squared minus 3x plus 1, giving us 15x squared minus 9x plus 3. And again, we're going to go ahead and subtract this. But maybe you're not so good at subtracting with negatives. Maybe you think you're inclined or prone to make a mistake with that. So what we can do instead is instead of subtracting, subtracting the same thing as adding a negative. So we just now flip all the signs. We'll make the outside a plus sign, but now we flip all the signs in the problem. And the advantage of this is, since you're used to looking at a vertical column when you're adding or subtracting and just seeing what the numbers are in that particular column, this is a little bit more visual, a little bit easier to see. 15 plus negative 15 cancels. Negative 8 plus 9 is 1. 2 plus negative 3 is negative 1. There's our answer. You get the same answer by subtracting, by not flipping the signs there. You just have to be careful with your negative signs. That's the only key with that. And we're done at this point. We know we're done for 2 reasons. One, there's nothing more to carry down. Unlike long division with numbers, we can't do like decimals there, so there's nothing else we can do. And then second, the variable term that's left over, its exponent is less than the exponent on the outside. So if I'm dividing by an x squared, I know I'm done once my bottom expression is either a linear term or just a constant. There's nothing else there, then I know I am done with that. So we go ahead and say our final answer is 2x plus 3, and then plus the x minus 1 over 5x squared minus 3x plus 1. That's our final answer. And so the idea is we're just simply going through a long division process and just kind of seeing step by step, first term inside, divide by first term outside, multiplying the top to the outside there, subtracting by then adding the opposites, and then just repeating the process until we no longer have an expression that is big enough to divide into. All right, so if you take a look at this one right here, example number 2, we want to divide x squared plus x plus 4 into the x to the fourth expression. So we'll set it up. And when setting this up, we're going to notice something interesting. There's no x cubed term in this expression. It goes from x to the fourth to x squared. Anything that's missing, we should put in a 0 term to represent a placeholder for it. The reason we want to do this is very simple. It's going to allow everything to line up nicely. Because we're probably going to create x cubes term when we go ahead and multiply the whatever we get up top to the outside. So we want things to line up in a nice fashion. It's also a good practice when we talk about synthetic division in the next couple examples where the 0 term is necessary to do the problem correctly. So that's why we kind of want to put it in there wherever possible. All right, so again, first term inside, the x to the fourth, divided by first term outside, x squared gives us x squared. Then multiplies the x squared plus x plus 4, giving us x to the fourth plus x cubed plus 4x squared. And we subtract. So we're really adding the opposite, so we flip all our signs. X to the fourth plus a negative x to the fourth cancels. 0x cubed plus negative x cubed gives us a negative x cubed. And then 9x squared plus negative 4x squared gives us a positive 5x squared. We carry down our next term. Again, we do first term inside, negative x cubed, divided by first term outside, x squared. We get negative x. The negative x then multiplies to the outside expression, giving us negative x cubed minus x squared minus 4x. And then we flip all the signs, or all those negatives now become plus signs. And the negative x cubed and positive x cubed canceled. 5x squared plus x squared is 6x squared. 23x plus 4x is 27x. And then we carry down the negative 5. And then for our final step, now again it's first term inside 6x squared, divided by first term outside x squared, we get a positive 6. And that 6 then multiplies the outside expression, giving us 6x squared plus 6x plus 24, where we subtract. Again, we flip all our signs, giving us a positive 21x and a negative 29. Our exponent is now less than the exponent on the outside. We create a linear remainder. There's also nothing more to carry down, so we know we're done. And our final answer is x squared minus x plus 6 plus 21x minus 29 over x squared plus x plus 4. And that's our polynomial long division. Useful when we're dividing by x squareds or x cubes or anything else like that. Not the best method to use if we're ever dividing by a linear expression, though, because there's obviously more efficient ways, and that's what we call synthetic division. So it's much simpler because it's going to use the coefficients and kind of like almost like a trick pattern it recognizes on how to go through the numbers without having to write out all that extra stuff. The problem, of course, is synthetic division will only work if there's a coefficient of 1 in front of the variable. So if there was like a 5x plus 2 we were dividing by, we'd have to divide everything by the 5 first to get rid of that to then be able to actually solve out the problem. It also doesn't work if the polynomial's got a degree of 2 or greater. So if we're dividing by an x squared or an x cubed or anything else like that, we can't use this method. This method only works if it's a linear binomial expression. So the way it's going to work is very simple. We're going to set up like a half a rectangle, sideways L. On the top, we're going to essentially think of it as like 2 rows. The top row is going to be the coefficients of the problem, 8, 22, 9, and 13. We're going to leave spaces, so there's room in between them so we don't like merge numbers together. And then on the outside, in that same row, but on the outside of the bracket, we're going to put the opposite of x plus 3, so a negative 3. Always the opposite. So it's not like it's absolute value, just simply the opposite expression. X plus 3 yields negative 3. And then the first term is going to get carried down. And now any term on the bottom is going to multiply to the outside and go in the next available space in that second row underneath those numbers in the first row. So 8 times negative 3 is negative 24. Numbers are in the same column, then add together. 22 plus negative 24 is negative 2. And then again, numbers multiply. Negative 3 times negative 2 is positive 6. Then the column adds. 9 plus 6 is 15. And then the bottom and the outside multiply. 15 times negative 3 is negative 45, which we then add one last time and get a negative 32. So our answer, well, we need to recognize what each of these numbers represent. So working right to left, the first number on the right is the remainder. And then so we have the constant, our variable squared. If there was more numbers, we then have variable cubed, variable fourth, and so on. So the final answer would be 8x squared minus 2x plus 15, and then minus 32 over x plus 3. All right, so it's a very quick and easy process, especially once you get very good at what's happening. You can really just blow through these questions very, very quickly. Just make sure you're careful to add correctly, make sure you're putting the right number on the outside, and then most importantly, make sure if there's a term missing, you include a 0 there. So like we had talked about for the long division, we had a missing term, we should put a 0 in place. You don't necessarily have to for long division because you can still do it correctly as long as you're careful. With synthetic division, if you don't include the 0, because it's a shortcut method, it is not going to do it correctly. So we'd have a 4, then our 0, negative 95, negative 32, positive 38. The 0 has to be there in between the 4 and the negative 95. And again, any variable that's missing needs a 0. If I didn't have the plus 38, just ended at an x, I would need to put a 0 at the end of the problem. Everything after the highest term needs to be there. You need to make sure whatever the exponent of the problem is, it's x to the 4th is the highest power. I've got 5 terms in, one more than whatever the highest exponent is. And if I don't have 5, you have something missing. All right, so we carry down our 4, and again, bottom multiplies to the outside, and then the numbers in the column add. And again, this is kind of like a little illustration of you can work through this pretty quickly as long as you're comfortable with the quick mental math, the multiplication and adding. If you have to work through it a little slower than that, that's perfectly fine. Just make sure you're being careful. Bottom multiplies to the outside. First row and second row add together in that same column, and then you repeat the bottom multiplies to the outside all the way through. And again, this is our remainder, our constant, our variable squared, and our variable cubed. The final answer should also be one exponent less than what you started with. So if you forget a term, you're not going to have that done correctly. So that's why we work right to left, so we can make sure that, oh, okay, this is the remainder, this ends at x cubed, that's one less than where we started, then we're okay. So we'd have 4x cubed plus 20x squared plus 5x minus 7 plus 3 over x minus 5 for our final answer. And that's our synthetic division. You want to make sure you are comfortable with that. We're going to be using this a lot in 2.5 to solve equations. So you want to make sure this skill doesn't go away. The polynomial long division skill will also be used, not as often really this year, but it does get used at different points in the calculus curriculum as part of like integration, integrals, antiderivatives, stuff like that. So make sure you're comfortable with the idea behind polynomial long division. All right, next up, I'm going to be giving you everyone solutions to a function, and you're going to write the function based on the solution. So I'll see everyone next time for that.